All right, everybody. In this video, we are getting into vectors. So, what a vector is, if you don't remember from pre-cal, or if you did not have that instruction, let's talk about it for just 1 second. A vector is something that is acting with a direction and a magnitude. So, if you watch the original Despicable Me, it's that vector dude. That's what he's saying. He's actually defining what a vector is by saying, well, direction and magnitude, whatever he's saying. I don't know. But it has both an x direction and a y direction. If something is acting with a vector of, let me change it to match the situation, for 3 maybe, that means it has an x direction strength of 4, a y direction strength of 3, and an overall direction strength of 5, a magnitude of 5. So this thing may be acting at, I don't know what this is. This is 36 or 40, let's say 40 degrees. I don't know. This is probably not right because that's definitely not right. But whatever the angle is that it's acting with, I can tell where it is pushing or where it is throwing or where these forces are being applied to this. And then I can try to counteract it with multiple forces if I want to and make it such that the resultant vector is 0. But there's different things we can do with vectors. There's also vector fields with differential equations that kind of show whether something is stable or not. I do believe that is the idea behind those things. 17% battery. Finish this. But that's kind of the gist of vectors. But essentially, they are very, very similar to how we treat them in calculus to how we treat parametric equations. So if this is the position vector, the velocity is the derivative, and the acceleration is the second derivative. Speed is the magnitude of the velocity vector. So if I look at the velocity vector, and I have x prime and y prime, speed is the Pythagorean theorem. So essentially how fast it is moving is how fast it is moving in the x, as well as how fast it's moving in the y, how fast it's moving all together. That's all that this is saying. Okay. So speed is the square root of dx dt. Here, let me just do x prime squared plus y prime squared, which if you remember looks very, very similar to our total distance traveled, the arc length, right? So the arc length, or distance traveled, is the integral from a to b of this equation, dt. Right, so those are very two similar things. Okay, particle is modeled by these two equations. These are just parametrics, right? But if I wanted to model it with a vector, I could say that this is t cubed plus 4t squared and t to the fourth minus t cubed. That is the vector form of this particle motion. Find the velocity vector when t equals 1. First, I need to find the velocity vector, and that's just taking the derivative. So 3t squared plus 8t, and then 4t to the third minus 3t squared. Now when t equals 1, the velocity vector is just when I put in 1 for t. So I have 3 plus 8 is 11, 4 minus 3 is 1. That is my velocity vector when t equals 1. Find the acceleration vector when t equals 2. First, I need to find the acceleration vector. So 6t plus 8 and 12t minus 6t. And then if I put in 2, let's see, that's 12 plus 8 is 20. And I missed a squared here. 12t squared, yeah. So 48 minus 12 is 36. There's the acceleration vector when t equals 2. The magnitude of the velocity vector when t equals 1. The magnitude of the velocity vector, this is the speed. The magnitude is just the length of the velocity vector. So if I'm looking for the speed here, I already have the velocity vector when t equals 1, so I don't need to do a whole ton of work. If I didn't, I would need to, but this is just 11 squared plus 1 squared, which I can rewrite as 122 if I want to, and I would like you to say that the speed equals this amount. All right, that's it for that example. Again, these really aren't that much different from parametrics. Okay, particle moves in the xy plane such that x is this, y is this, where I'm limited on the unit circle essentially. Set up an expression to find the distance traveled between the two x-intercepts. So first I need to figure out where the x-intercepts are, and if I have an x-intercept, that means the y value is 0. So if I solve this, 1 minus 2 sine of t, then sine of t equals 1 over 2. That will happen when I have pi over 6 and 5 pi over 6. You will still need your unit circles. Please remember that. Unit circle or triangles, however you have it memorized. But this is the two that I will be going between. So it'll be pi over 6 to 5 pi over 6. And then the distance traveled is just going to be, I'll need to find x prime, I'll need to find y prime, and then do Pythagorean theorem with those two things. So this will be the square root of x prime will be 4 sine of t squared, and y prime will be negative 2 cosine of t squared dt. And that's it. That's all I need to write there. All right. Example 3, I think this is the last one. It's also a calculator question, so if you want to pause the video and have a calculator out, you're more than welcome to. Write an equation of the line tangent to the curve at 4, negative 2. That's nice they give us a point. So really all that I need to find is dy over dx at that point. And it tells me at time equals 2, the object is at this position. So I need to find dy dx when t equals 2 is really what I'm looking for. But I'm going to go ahead and just find dy dx first. So dy dx, just like with parametrics, I need to take dy dt and divide it by dx dt. So dy dt is cosine of t cubed over 2 sine of t squared. And that is dy dx. So now dy dx, make sure you're in radians. You just need to do at t equals 2. So that's cosine of 8 divided by 2 sine of 4. And that comes out 0.0551. All right, cosine 8 radians. Yeah, I think that's right. So then I have y equals negative 2 plus 0.0551 and x minus 4. There's my line tangent. Find the speed of the object at time equals 4. So I need to do the square root of x prime of 4 squared plus y prime of 4 squared, and see what that comes out as. So I have cosine of 64 squared plus y prime, so 2 sine of 4, 2 sine of 16 squared, and I'm getting 0.4851. I don't remember these numbers, so I hope this is right. All right, find the total distance traveled on the interval 0 to 2. So all that is the integral from 0 to 2 of x prime squared plus y prime squared dt. Okay. Here. All right, for that I'm getting 2.7580. That seems more recognizable. So I think these numbers are good. Okay, find the position at time t equals 4. Well, I know the position at time t equals 2. I know it is 4, negative 2. So what I can do is if I go from 4 and then I add the displacement from 4 to 2 to 4 of the x1, and if I go from negative 2, right? Yeah. And I do the change in the y, that will give me where I end up. So let me take a second to type that in. And this comes out as these numbers. So that is my position after 2 seconds of more travel. Okay, hopefully this video was short and sweet and helpful. Again, just treat them pretty much like parametrics. They're not really that much different from what we've been doing up to this point. Other than that, let me know what questions you got, and I will talk to y'all soon. Well, bye!